In this video, we are looking at trigonometric functions and the chain rule. So, remember when we talked about the chain rule, the definition, we used a u to say that u is a function of x, so that denoted that it was a composite function. We're going to do the same thing with all of our trig functions. We're going to say sine of u. In this case, u is just some function of x. This is u is some function of x. So sine of u is going to be the cosine of u. Leave that function alone, but then take the derivative of that function. It's the same thing we do with u to the n, right? So if we're talking about d dx of u to the n, we bring the n out front, leave the u, do n minus 1, but then we have to do u prime. We have to take the derivative of that function. Same thing here. We treat sine, tangent, secant, cosine, cotangent, and cosecant the same way we did before, but we leave the argument alone. All right, so first step is just take the derivative, leaving the argument alone. Second step, tack on the derivative of the argument itself. Okay, so examples. Y equals sine of 2x. What's the derivative? Well, the derivative of sine is cosine, right? And we leave the argument alone. But we do have to tack on the derivative of the argument. So we get 2 cosine of 2x. What about cosine of x minus 1? Once again, we have the cosine of a function. So what's the derivative of cosine? Negative sine, leave the argument alone, but then tack on the derivative of the argument. So we just get negative sine of x minus 1. What about tangent of 3x? Same deal. Derivative of tangent is secant squared, leave the argument alone, but then we have to multiply by the derivative of the argument, and we get 3 secant squared of 3x. So that's all you have to do when we talk about trig functions in the chain rule. So let's look at a complete breakdown of everything that we have learned in terms of differentiation. We've got our general differentiation rules. The derivative of a constant is 0. Simple power rule. This is just when we have x to some power. Bring that out front, decrease the exponent by 1. Constant multiple rule. If we've got c times some function, we just multiply the constant times the derivative of the function itself. And notice that we're jumping over into this u version where u is some function of x. Sum or difference rule. U plus v is just u prime plus or minus v prime, where u and v are just functions. Product rule. U times v is now uv prime plus vu prime. First times the derivative of the second plus second times the derivative of the first. Derivative of a quotient, u over v. Low d high minus high d low over low low. Now we've got our chain rule. Derivative of a function of u. We take the derivative of f, and then we take the derivative of u. General power rule, bring the n out front, decrease by 1, and then tack on the derivative of that inner function. And then the last thing we just talked about, sine x, cosine x, tan x, cotan x, secant x, cosecant x. These are your basic trig functions, but we want to change them so that we say d dx of sine u equals cosine u, u prime. Oops, went too far. Same thing with all of these. If we change the x to u, and then we tack on a u prime. U prime. U prime. Oop, not u prime yet. U prime. And then here we've got u prime, u prime. If you have any questions about any of these, please don't hesitate to shoot me a reminder or ask questions in class.